Hello. By the end of this video, students will be able to add rational numbers, focusing on fractions and mixed numbers. So in order to add rational numbers, we actually use the rational rules of addition in order to find the sign of the answer and determine which process you're going to use for those computations. As a reminder, your rational rules of addition are, if you're adding two negatives together, you're going to get a negative as an answer. In order to find the value of that negative, you simply just add the absolute values together. So a fun little phrase that I like to use to help remember what to do when we're adding two negatives is same sign, you take the sum, and the sign stays the same. Okay, so same sign, you take the sum, the sign stays the same. What that means is if they're both negative or both positive, it works for either, okay, and you're adding them, you're going to simply add the absolute values, so find the sum of the absolute values, and the sign will remain whatever the values are, negative or positive. When you're adding one negative and one positive, whether the negatives first or the negatives second, you're going to end up subtracting the absolute values of the given numbers. In order to determine the sign of the answer, you have to ask yourself, what do you have more of? Do you have more negatives or do you have more positives? In other words, you're going to keep the sign of the value with the greatest absolute value. Okay? So whether it's the first value, the rational number that's given to you, or the second rational number, whichever one has the greatest absolute value, that's the one that's going to be left into your answer. So let's take a further look at this process using an example. So the first example is -2 4/5 plus -3 2/3. Step one in this process is to first see which one has the greatest absolute value. We do this just in case we need it later on. Now, the greatest absolute value here is a little more obvious. We have 2 4/5, and the absolute value of -3 2/5 is 3 2/5. So the greatest absolute value is this -3 2/5. Now that we've determined which one has the greatest absolute value, we're going to use the rules to answer 3 questions. Whether the signs are same or different. If they're the same or different, are we going to add the values or subtract the values? So are we going to find the sum, or are we going to find the difference of the two absolute values? Then we need to ask ourselves, okay, what is our answer going to become? A positive or a negative? So taking a look again at the example, we're going to ask ourselves those 3 questions. Same or different? Both of them are negatives, so we're going to say same. Same signs, you take the sum. So are we going to add or subtract? We're going to add. And what I like to do at this point is, okay, I know I'm going to add already, so I'm going to go ahead and set up my problem. I'm going to add. And then the last question, our answer in fact is going to be a negative. We have 2 negatives and we're adding them together. So essentially we're digging ourselves that bigger hole. So we're going to end up with a negative in the end. Okay? And that's step 2. By the end of step 2, you should know that you're either adding or subtracting the absolute values and what the sign is going to be of your answer. That way you don't forget that sign at the end. The third step, in this process is to add and subtract like you would a normal fraction or mixed number. So we've already dealt with the signs and the negatives. So really all that's left is just the core absolute value. As a force of habit, I always like to put the greatest absolute value on top. Using the commutative property of addition, it says that it doesn't matter which order we add these values, it's going to end up the same. So I just make it a habit of always putting that greater one on top. Just in case we're subtracting, we're going to need to do that anyway. Okay? So we have 3 2/3 plus 2 4/5. We're going to need a common denominator in order to add this normally. Looking at the denominators of 5 and 3, our common denominator is going to be 15. Then, figuring out the equivalent fraction for each value, well, 3 times 5 is 15. So, to keep it equivalent, we must also multiply the numerator times 5 and get 10. When we reduce 10/15, we should end up with 2/3, which in fact we do. That's how we know we did it correctly. So 5 times 3 is 15. So 4 times 3 is our computation at the top. We're going to end up with 12. Okay. Now we're going to add the numerators. Remember, keeping the denominator the same, we just add the numerators. These are now equivalent pieces, so we can put them together. 10 plus 12 is 22. Denominator stays the same. And go ahead and finishing this, we're going to take 3 plus 2 and get 5. Okay, our answer is -5 22/15. However, that answer is improper as 22 is greater than 15. So you can think of this as a pie that's overfilling. So we need to figure out exactly how much leftover do we have. So, finishing up here, we're going to take and figure out if we have 22, how many 15s can we take out? We can take out one group of 15. That's one whole pie for all intensive purposes. So 22 minus 15 is going to be 7. What this means is in this fraction here, we have 1 whole and 7/15. We just changed this fraction to 1 and 7/15, making sure that we also include the 5 here. We're going to have a total of 6 and 7/15, and don't forget the negative. So let's go ahead and continue with another example. What if we have, for instance, 2 5/6 plus -2 7/8? How would we handle this type of problem? Well, it's still mixed numbers. We still see a negative value there, so we got to remember our rational rules. Step 1 of our rational rules says to figure out which one has the largest absolute value. Okay. Both of them are 2 as a whole number, so we got to look deeper into the fraction. Not too many of us can decipher whether 5/6 or 7/8 are larger or is larger just by looking at it. So there's a couple of tricks that we can use. So what we're really doing in reality is we're comparing these two fractional parts. Now, we may have seen this before, but this is just a review. Let's dive in. There's a couple ways to solve. The first way is to actually find the common denominator, and then from that, utilize the numerators in order to see which one's larger. So the common denominator here of 6 and 8 is going to be 24. 24 is the least common denominator, as in it's the smallest value multiple that both of them have. Okay. Finding our numerators then, we're going to multiply 7 over here by 3 and get 21. And then we're going to multiply 6 over here by 4. So inevitably, we're going to multiply the 5 by 4 and get 20. Now we have a better idea because we have 20 24ths and 21 24ths. Let's get this out of the way. We now can visually see that 7/8 is in fact larger than 5/6. Another way we can figure out which fraction or mixed number is larger is by using cross products. So what we're going to do is we're going to pretend that these are equal. If in fact they're equal, the cross products should be equal. If the cross products are not equal, then whichever one is larger, that's your largest fraction. So 8 times 5 is going to be 40. 6 times 7 is 42. 42 is greater than 40, which verifies our conclusion in the beginning that 5/6 is actually, in fact, less than 7/8. This tells us our second mixed number is our larger number. So we're done with step 1. We've identified the one that is larger. Step 2. Step 2 is to answer those 3 questions. Now, you may be able to do step 2 in your head, but as always, I recommend you setting up your problem. So we're going to ask ourselves, are they the same sign or different signs? In fact, they are different. Different signs, we're going to take the difference, which means to subtract the 2 values. So I'm going to come over here and put a subtraction sign on the math problem. Then we need to ask ourselves, what do we have more of? So what is the sign of the answer going to be? We have more of this one, this second rational number. And that rational number is in fact a negative, so our answer is also going to be a negative. Now we can set up the problem and solve it like we would normally. Placing the greatest absolute value on top comes in handy. Okay. We've already figured out the common denominators here so that we can subtract. We have 21 24ths and 20 24ths. Doing the rest of the problem, 21 24ths minus 20 24ths, well, 21 minus 20, we're left with 1 24th. Another thing I generally recommend is just crossing these out, because we don't need those fractional parts anymore. We need the equivalent fraction to those so that we can add or subtract them properly. And then we deal with the whole numbers. So we have 2 minus 2, which ends up being 0. Our final answer, we don't write the 0, is negative 1 24th. So hopefully this video provides you with an in-depth knowledge of trying them on your own. So here's what I would like you to do now. Go ahead and try these values. Try these examples on your own. Six and 4/5, negative 6 and 4/5, plus 4 and 1/2. Try them on your own and see what you get. So go ahead and pause the video and see what you get. Now that you have paused the video and tried the problem, your answer should have been 2, negative 2 3/10. In this video, we have practiced and introduced adding rational numbers, focusing on